Solve the equation negative 7/20 equal x minus 9/16. Before we get into the actual solving the equation, let's just think out loud for a moment. Now I know that I want to solve for x, or solve for the variable. Therefore, I want to end up with something like x equal something, or it could be something equals x. It doesn't matter which side the x is on. Also, I'm looking at the equation and I'm thinking, well, I'm used to the x being on the left side, so I think first thing I would probably do would be to move the x over. In order to move it, I would have to subtract, right, on both sides. And if I subtract on both sides, I'm going to have a negative x. No, we don't want to have negative if we don't need to. So, won't do it. We'll just leave x where it is. That's some of the thinking I do when I solve equations. So, let's do that. Let's actually do that. We're going to leave x on the right side. Instead, we're going to use the addition property of equality to move 9/16. And what I tell my students said, whatever you see here, just do the opposite. So you have a minus 9/16. That means that we're going to add 9/16 to both sides. And so it will be negative 7/20 plus 9/16 equal x minus 9/16 plus 9/16. Alright, that will get rid of the numbers on that side. It isolates the x. And now I can simplify the left side. However, there are fractions and they have different denominators. That means I have to do a little more thinking. I need a common denominator. More specifically, we want the lowest common denominator, LCD. The method that we're going to use will be prime factorization. So we're going to go to the side and determine our LCD, because, well, those numbers are too large. I don't really know it at the top of my head, so that's okay. We will just pull out one of our math tools, prime factorization, and figure it out. So for 20, we're going to start with the smallest, 2, 10. 2 is prime, so I circle it. 10 is composite, so I continue. It means it has more factors besides 1 in itself. So let's go 2 times 5, and they're both prime. Circle, I stop. So my prime factorization for the 20 is 2. How many 2's do I have? 2. So I'm going to do 2 to the second power times 5. Let's do 16. Prime factorization for 16. 2 times 8. Circle the 2. Continue with the 8. 2 times 4. Continue with the 4. 2 times 2. And I have all my primes circled. The prime factorization for 16 is 2. How many 2's? 1, 2, 3, 4. 2 to the 4th power. Okay, you say, okay, we did that. Now what do I do with these numbers to find out the LCD? I am so glad you asked. All we have to do is make sure that we use each prime number in determining the LCD. So we have used 2 in the 20 and we've used it for 16. Which one do we use? We use the prime number, in this case 2, that has the highest exponent, which would be 4. And then we add the 5 in that expression. And so we have 2 to the 4th times 5. The LCD will equal 80. Alright, remember LCD stands for lowest common denominator. So we take that back to the problem, and we're going to use 80 as our new denominator to create some equivalent fractions. Let's write this vertically this time, and I'm going to start with the 9/16, and it's going to be a minus 7/20 or negative 7/20. And what am I putting here? 80, because that's what we determined to be our new denominator. Now my job is to create equivalent fractions here. So 16, I asked myself 16 times what will equal 80? It will be 5. We just did that over here. So 16 times 5 equals 80, and I will multiply the numerator by 5. So 9 times 5 is 45. Notice that what we have here is 5 over 5, which is 1. That's why it does not change the value. The next fraction, 7 over 20. 20 times what will give me 80? 4. So I multiply my numerator by 4 as well. And 7 times 4 must be a negative 28. We have just created equivalent fractions. With that, we can subtract. And so we have 45 minus 28 will be 17 over 80. X equals 17 over 80. Let's look at that again. In summary, here we have the original problem. We added 9/16 to both sides, and then so that on the right side became x minus 0. We don't need that, and that's just x equals. And then we created equivalent fractions. Now notice that although we have same denominator, we have different signs, and when we add different signs, we have to subtract the absolute values, which is what I've just shown you here, just for a reminder. The absolute value of that's a negative 28/80 will equal a positive 28 over 80, and so on. At this point, I highly recommend you review the lesson until you have a good understanding. And if you have any questions, please contact me.